Hello, everyone. Welcome to another episode of the Engineering Student Experience Podcast. I'm Paul Nissenson from the Mechanical Engineering Department at Cal Poly Pomona. One of the greatest ideas in all of human history is the heat engine. Heat engine is a generic term for a device that converts thermal energy from a source that has a very high temperature into mechanical power, typically in the form of a spinning shaft. Some common heat engines include gasoline engines, diesel engines, jet engines, coal-fired power plants, and natural gas-fired power plants. Heat engines allow goods and people to be transported across the country and around the world at speeds that would have been unthinkable 100 years ago, and they allow us to have access to a seemingly endless supply of electricity. You are listening to this podcast on an electronic device, and most likely part or maybe all of the electrical power that is running the device was originally generated by a heat engine. Most heat engines still use hydrocarbons as their source of thermal energy. Hydrocarbons like gasoline, diesel, aviation fuel, and natural gas are used because they are relatively easy to transport, they can be stored for long periods of time until needed, and they contain a lot of energy in the form of chemical bonds that's released during the combustion process. But it takes a lot of effort to create these fuels. It starts with hydrocarbons being extracted from deep underground reservoirs where they're under tremendous pressure. The crude oil and natural gas that's extracted from the reservoirs is then transported to large facilities called refineries. Now, crude oil is a giant soup of many different hydrocarbons, and both crude oil and natural gas have impurities. At the refinery, the crude oil is separated into various components in a process called fractional distillation, and those components must undergo further processing to become usable. Along the way, most of the impurities in the crude oil and natural gas, like sulfur, are removed. The refined products are then transported to where they're needed, like a gas station or power plant. Although renewable forms of energy like solar and wind power, as well as electric vehicles, have been steadily gaining market share in the past couple decades, we likely still will need fossil fuels for the foreseeable future to help meet the very high energy demands of society. And besides fuels for heat engines, crude oil and natural gas also are used to make many products that we use in our everyday life, like plastics, rubber, lubricating oils, waxes, asphalt, many types of chemicals, and hydrogen fuel. You likely are familiar with some of the largest energy companies in the oil and gas industry because you see their names on gas stations. Energy companies like Chevron, ExxonMobil, and Shell have operations in every area of the oil and gas industry, from extraction to transportation to refining, and finally delivery to the customer. Joining me today to discuss what it's like to be an engineer at an energy company are Justin Valencia and Brittany Williams, both of whom work for the Chevron Corporation at its refinery in El Segundo, California. Justin has a background in mechanical engineering and is the Technology and Innovation Manager for Downstream, Midstream, and Chemicals. Brittany has a background in chemical engineering and is a short-range process engineer. During the interview, Justin and Brittany describe what their day-to-day work is like at a refinery. They discuss the various activities engineers are engaged in throughout the refinery and throughout Chevron's many other operations. And finally, Justin and Brittany discuss how engineering students can better prepare themselves for a career at an energy company like Chevron. Before we jump to the interview, I'd like to thank Justin for hosting me at the El Segundo refinery, which is where we recorded the interview. After we finished the interview, he gave me a tour of the refinery, which was really interesting for me personally. I teach a course on air pollution at Cal Poly Pomona, and it was pretty neat to see all the pollution control equipment throughout the refinery. It also is really interesting to see all of the other refinery equipment up close. I definitely gained a much greater appreciation for the massive scale of operations that are required to meet the energy needs of our society. So now let's go to my interview with Justin Valencia and Brittany Williams. I hope you enjoy the conversation. All right, well, I am on site at a Chevron refinery in El Segundo, California. And joining me today are two engineers at Chevron. We have Justin Valencia and Brittany Williams. Thank you so much for joining me today.
You're welcome.
Thanks for having us.
So before we jump into what Chevron's all about and what it's like to work at Chevron, I'd like to get a little background information about you both. So What was your educational background? Do you remember when you first started getting interested in engineering? What was your career path to get you where you're at today, and anything else you think the audience would be interested in?
Well, my name is Brittany Williams, and I started off with attending Cal Poly Pomona, so alumni, go Broncos.
What year?
I graduated in 2021, so have been with Chevron full-time for about 4 years now. Grew up in Southern California, was a commuter to Cal Poly, started in the fall of 2017. What got me interested in chemical engineering, I think kind of the cliche answer as always is interested in mathematics and chemistry throughout high school. I also wanted to get into something that was a little bit more hands-on. I was always interested in building connects, building Legos, so wanted to be something where I could use both technical background but also get that hands-on experience. My dad was also an aerospace engineer, so he also kind of exposed me to things and technical field early on, which gained my interest in kind of STEM-related fields. So started off at Cal Poly, as I mentioned, in fall of 2017. Was a sophomore attending career fairs and saw Chevron at the engineering career fair, went up to their career booth, was successful in getting a internship for the summer in between my sophomore and my junior year. So in 2019, I was a coker operations intern where I was on shift work, got a lot of hands-on experience with operators that run the plant, got exposure to real-world applications of chemical engineering disciplines, which I think was really exciting because typically an internship, you would think it's secretary work, but Chevron's internship program definitely provides a great experience related to experiencing and applying your skills from school, but then also learning how to apply that to real-world applications. Then I had a returning offer for 2020. Unfortunately, COVID happened. It was supposed to be an on-site process engineering internship, but I got the experience to do a virtual internship for Chevron that year. Got a lot of exposure to how Chevron worked as a whole from both our upstream, midstream, and our downstream applications. And then got a return offer as a designs engineer in the summer of 2021. So that was actually more mechanical engineering based, so more on the design side, working with small bore piping designs, small and large capital projects. And then was there for about a year and then moved over to our process engineering department where I've had experience on our hydrogen, amine, and now our coker plants. So been able to utilize my chemical engineering discipline and knowledge to help with problem solving, troubleshooting, and also process optimization, trying to optimize our yields of our high-value products in the refinery.
Hi there, my name's Justin Valencia. I have similar background to Brittany. I'm a Cal Poly alum, graduated in 2003 from the Department of Mechanical Engineering. My interest in engineering, of course, started young also. Legos and construct and building forts and those fun hands-on activities involved around the house with my parents and grandparents and taking things apart or building things. So the hands-on mechanical aptitude part was always of interest to me, and so that was a natural progression. Also, having affinity for math and science and going through various support programs, MESA program in middle and high school, and being part of that. Actually, in high school, I was in a program for exposure to the oil industry, and so that kind of joined my mechanical interest with energy interest, and that's what led me to Chevron and a career in energy.
What has your career path been like within Chevron?
Getting here, I had the opportunity to have an internship as a freshman, and so we've got a unique program where we actually look for freshmen. We still do some of that in the underclassmen groups. Did actually 4 summer internships, came back and was on crew with operations, running plants, and then back for 2 technical summers. From there, hired on full-time here in El Segundo. Physically been primarily located here in El Segundo, various roles in what we call plant support organizations, doing anything from thermo, fluids, hydraulics, vibrations, stress analysis on the equipment here to keep it running and reliable. Progressed through that into some technical leadership roles, into maintenance management, and now in my role as technology and innovation manager, I'm looking to apply novel technologies to our 100-plus-year-old business.
So if you can provide me with a high-level overview of Chevron. So what kind of products does it produce? What kind of activities is it engaged in? And where are you going to find different types of engineers in all those different activities?
So Chevron's a global energy company. You're listening to this, you're probably here in the LA area, and so you're going to recognize us from our Chevron and Texaco stations. But globally, we've got brands. Caltex is one of them. You'll find a lot in Asia. You may see our lubricants with Haviland brand. And so there's a handful of kind of on the consumer side where you'll see Chevron and some of our legacy products. I'll say behind the scenes and behind those consumer products, we've got a whole company that starts all the way from looking for and exploring places to get oil and natural gas from. Our upstream part of the business, which is what that's called. They look for it, they find it, and they get it out of the ground. We have a midstream part of our business, which deals with moving, crude oil and products around from our facilities and to and from other facilities. And then we have where we work here in El Segundo, a refinery, which takes those raw products like crude oil and turns them into usable products, gasoline, jet, and diesel.
Would that be the downstream?
That's our downstream. In addition to that, we've got other parts of our business, our Chevron New Energies group, which is really looking at combining our kind of known skill set on developing and bringing products and energy to fruition, exploring lower carbon opportunities with carbon capture, sequestration, hydrogen, those type of opportunities. So you'll see us in that business as well.
Yeah, so you mentioned how most people know Chevron through gas stations as they drive around. On the way here today, I saw one at the corner of PCH and Pacific Coast Highway and El Segundo. And I think most people don't appreciate the amount of effort that it takes to get a gallon of gas into their vehicle. And you were just touching upon that, Justin. Can you describe the details behind the entire pathway that that gallon of gas took before it got into that person's vehicle?
Yeah, it's an awesome journey. The reserves and places that crude oil is found in the earth, we've drilled wells as deep as 30,000 feet, right? So that's drilling from an airplane, right? So when you're up flying on your way to wherever, right? Some typical flight elevation, 30,000 feet in the air, we're drilling down into the earth to get these reserves out. And so it takes a lot of engineering and technology and support to make that happen. Finding it alone, anything from seismic imaging to all the equipment that we put on the bottom of the sea floor to extract and move pipes that move the oil around, to collecting it and processing it. That oil will come out of the ground at several tens of thousands of PSI. And so that oil is collected. It's got some kind of high level separation from natural gas. And so the natural gas will be processed separately, and the entrained water will be processed separately. But the oil comes off of that and into ships or into subsea pipelines, or if it's land-based oil wells, right into pipelines and gathering stations. From there, it'll be pumped to gathering locations or tankage and sold to on the market. A large part of our business is a supply and trading organization, and the oil that we produce from the ground may or may not end up in a Chevron facility. It could end up in a Chevron facility. We partner very tightly with the oil field up in San Joaquin Valley. And so a majority of what we produce up there comes here, but that's not always the case. Once that oil gets to a refinery.
And at this point, it's a giant soup of different hydrocarbons and stuff you don't want as well, right? Like sulfur and yeah.
Yeah, it's a good point. Maybe Brittany can talk about what it happens once it gets here in the refinery.
Yeah, so crude, so there are many different crudes around the world. And so as Justin had mentioned, our SJV or San Joaquin Valley is just a single source of crude. There are different crudes around the world that have different neat properties. They can be sweet, they can be sour, meaning they can either be high or low in H2S. They can also have high nitrogen, high metal content such as vanadium, nickel, which can be poisons to some of our downstream and hydrotreating catalysts. So typically when you feed crude to a refinery, it's not just a single crude, it's a certain blend that our planning sector definitely takes into consideration and looks at the trade-offs on the market, but then also the impact to that facility in itself. And so the crude units basically take the blend of crudes and they distill it by boiling point in a vacuum and also an atmospheric column. And they separate all of your hydrocarbons to be treated into your downstream plants to be made into high-value products like your jet, diesel, gas oils, and your MoGas or your gasoline blends. And so the downstream units, like our hydrotreaters, they use a special type of catalyst to perform desulfurization or denitrification to remove or convert some of the sulfur or nitrogen to meet our product specs. So those are only a small portion of our units here within downstream or the refining business that help to treat and produce our high-value products.
Kind of in addition, right, to us doing a lot of reactions to remove the things we don't want, we also do work to rearrange some of those molecules into things that we do want. And so the analogy of crude oil being a jar of Legos that you have to maybe stick together in a certain orientation that's a preferred orientation that turns into gasoline, or maybe some of those longer bricks you have to break apart into smaller pieces, and some of them you have to put together in a very unique way so you get the product quality that you do want. And so the drop of gasoline that you get out at the pump has gone through a number of these processes of either rearranging the molecules, cleaning the molecules, being filtered, being tested, and that happens in the refinery. Once the product meets specs in the refinery, it goes out to our distribution network. And so from these terminals, it's mostly trucked to your local gas station. At those terminals is also where we add Chevron, which is the number one additive. And so it gets to your car, your truck at the fuel station after traveling hundreds of thousands of miles, right, from its original source as crude oil.
So in addition to mechanical engineers and chemical engineers, what type of other engineers are involved at different stages of the creation of this product we call gasoline?
So I know Cal Poly itself has chemical and materials engineering, at least on more of the process side, but I can touch a little bit on what materials engineers applications are within a refinery. So, right, there's many different types of processes that happen around the refinery. And so material selection and metallurgical considerations are definitely where materials engineers play a key factor within the refinery. They help to analyze and provide their technical support in metallurgical upgrades to consider different types of corrosion mechanisms related to the process fluid that is going to be traveling through inside the pipes, but potentially any contaminants that it could impact metallurgical selections as well. So, like for instance, salt buildup is definitely common on overhead of many main fractionators or distillation columns in the refinery. And so those salt considerations will need to be considered because stainless steel is definitely susceptible to corrosion mechanisms like chloride stress corrosion cracking. So some metallurgical upgrades are definitely some things that materials engineer do provide their expertise in, just to make sure that the integrity of the material is reliable and robust for the different materials being transported through. Some other engineers, we have civil engineers on site. They definitely are PE certified, and they help to ensure that all of our structural integrity of all of our pieces of equipment, all of our new platforms, etc., are seismically and structurally equipped to all of the latest standards. And I'll hand it over to Justin to talk about maybe electrical or some other types.
Yeah, and so in addition to chemical, mechanical, materials, civil, electrical engineers are used in two places, instrumentation and control, and then also in power. And so we look for folks with a power emphasis for that particular part of the business. In addition to that, a little bit of a niche are construction engineers. The refinery is, we serve almost as our own general contractor, and so we will go out and hire folks to come do work for us, just like you do at your house. And our construction engineering folks are involved in a lot of the planning and oversight of that work. In addition to that, we have a large environmental compliance team. And so there are environmental engineers in that part supporting our compliance activities. So from a refinery, I think that kind of is our engineers. I will say, we talked about upstream and midstream. Upstream in particular has some very specialized engineering opportunities. Of course, petroleum engineers, kind of a combination of geology and chemical engineering, and then some very specialized like marine structures engineering roles. In addition to that, we've got our whole kind of central support organization. We have our own IT function, and so we look for cyber engineers, we look for computer engineers, we look for computer science folks doing programming, and so there's a large group of folks there. And then I'll say maybe one other facet or part of the business is research, and that's where we have PhDs doing research on product development, catalyst development, tribology, and so those are also more in like centralized organizations.
So it sounds like you have every kind of engineer except maybe like aerospace.
Although we do, so we share a lot of similar concepts with aerospace: heat transfer, vibration, fluid flow. Unfortunately, no aerospace.
So this is a massive facility, and I'm going to get an opportunity to go on a tour after this interview, which I'm really looking forward to. Give me a preview. What am I going to see? What am I going to hear? What will it be like?
As a large facility in the middle of LA County, right, surrounded by a large community, as a refinery, we definitely take into consideration to not be seen, to not be heard, right? So we do take into a lot of consideration our impact on the community regarding sight, smells, and also hearings. So when you go around the facility, we definitely take into those considerations just to minimize that impact on the community. But as you go around the facility, you definitely see a lot of our major processing units. You'll see major industrial sized pieces of equipment like heat exchangers, distillation columns, furnaces, fire heaters, vessels.
These columns are, how tall are they? Like 100 feet, or I mean, they're massive. I saw coming in.
So when I was on our hydrogen plant, the tallest column in that unit itself was 235 feet tall. So the purpose of a distillation of being at least as large as it is that it has internal components such as trays, downcomers, weirs. And so the height of a distillation column is going to depend on how much stripping or rectification that you want to do within your distilling process. The larger the distillation column, the larger potentially separation that you're going to have between the molecules that you are sending through that particular column.
And I see some giant storage tanks as well for the finished products on site, right?
So those house some of our intermediate products, but also some of our crude tanks, but then also some of our sour water, which is processed at our ETP or effluent treatment plant on site. So each tank definitely has its own particular source in the refinery. We also have our cogeneration unit, which is our main producer of electricity and steam for the refinery itself. I think going around the facility, you will also see plumes, white plumes going around. That is steam that is produced and vented into the atmosphere that is cleaned and treated before released. Around the facility too, we do have all of our monitoring for all of our H2S, greenhouse gases, just to make sure that we minimize that impact on the community as well.
I wanted to add a fun fact to you asking about the tanks. I think we probably got over 150 tanks. Our largest tank batteries, you could actually play football inside of. They're 100 yards, right? So 300 feet in diameter. So it's pretty impressive, the size and the volumes that we've got on here.
I can't even imagine do you know how many gallons or I don't even know if you measured in gallons at that point, but
it's 540,000 barrels, and there's 42 gallons per barrel. So
okay. I'll let the listener pull out their calculator.
Put that in the comments.
Yeah.
Someone put that in the comments.
So we focused a lot of big picture stuff so far. We talked about what Chevron does. We talked about how this facility is like. I want to know now, what is it like for you to be an engineer here? What is day-to-day, week-to-week, month-to-month work like for you?
Yeah, so as a process engineer in El Segundo, our main focus is to keep the plants around the refinery working both reliably, safely, and also meeting product spec. And so in the day-to-day life of a process engineer, your main focus is going to be troubleshooting, right? Monitoring the plant, looking at key process parameters, ensuring conversions and yield of your plants are meeting plan, or based on the projected markets that are provided for that week. That could also include if something is potentially going off spec, or you're seeing a temperature excursion, or seeing equipment failing or fouling over time, just based on changes in feed material to your plant. That is where a PE comes into play in terms of making sure that you fully understand the problem. So that's going to be involving all of your key stakeholders on your management team, talking to operations to get their feedback on potentially any changes, because we are a 24/7 business. And then once you get a full big picture of understanding what potentially could be going wrong or what you can look to improve, that is where you need to fully understand the problem and sort of act on it. So is there any potential process moves that you can make? So for instance, on your distillation column, if any of your product cut points or your boiling points are off, do you need to change anything on your temperature profile, your pressure profile of your column? And so process engineers are a mixture of troubleshooting, looking for ways to optimize your plant, and to eventually maximize your yield and throughput for the plant, just based on the margin projections for whether jet is more favorable over diesel, MoGas is favorable over jet, etc. And so some other parts of process engineering is that you get to interact with a lot of different disciplines. So if you're trying to troubleshoot the installation of a new pump, involving machinery engineering, electrical engineering, going out into the field and fully understanding the hydraulics of your system on whether piping configuration is a factor in why a pump is not running, or is it something has changed in the material that is flowing through that is impacting the physical or thermal properties of that fluid, like viscosity, temperature, etc. So As a process engineer, it's not just looking at trends. I find great pride in going out into the field, interacting with operations, and understanding the bigger picture so that you can come to fruition in a solution once you come up with the solution to that problem.
I'll add in terms of from a mechanical, electrical, civil, engineer. Chevron uses engineers as problem solvers, right? That's the nature of the degree, right? And the folks interested in kind of getting into and understanding why things are working or why things are not working. And so we use that ability to come and solve problems. And so from mechanical engineer into electrical engineer, why is a piece of equipment failing? Why has it failed? Gathering information from folks who have, maybe the process engineering side or the quality control side of what the product flowing through that piece of equipment was. Perhaps you're involved in the materials engineers to gather that understanding of the problem. From there, you apply your technical skills, right? Strengths of materials, hydraulics, right? Figuring out the best solution. And their industry guidelines, ASME has a bunch of them, state, pressure vessel codes, internal Chevron specifications. You take all of those specifications and you take your troubleshooting and understanding of the issue and develop a solution. And so depending on what that problem is and the size of the problem, whether it's, like Brittany is saying, a pump is cavitating or a control valve is not operating or has eroded or sky's the limit here. It's a 115-year-old facility. Things break every day. And so we use engineers of all disciplines to understand that and then come up with a solution. And then, those problems, and Brittany was mentioning earlier about how we give our interns real world problems, right? Those problems start small with what we give like interns and can be as big as, large capital projects to resolve something, right? Maybe we decide we need a line from, one side of the refinery to the other to facilitate something, right? Then engineer and various disciplines of engineering will be involved in designing and then being around for installation and commissioning of it. So as a mechanical engineer in an operating unit, there will be, like Brittany's attending to kind of the issues of the day, you'll be involved in the mechanical aspect of that. And so, whether it's troubleshooting something that right now has got a vibration issue or not staying online or not passing enough flow, you'll be involved in that day-to-day troubleshooting and repair opportunity. You'll balance that with maybe some of these longer-term, larger projects that you're maybe working with a vendor to get a quote for something. You may be working with other disciplines to get input on something, and so you balance that. And throughout the day, right, you may be out in the field, and it's 1,000 acres. Actually, the refineries that 1,000 acres, and it's cool because we have bicycles, and so part of your day may be you hop on your bike and you go out to the plant and you're climbing up some of these towers, you're climbing on equipment, you're going to talk to operators, mechanics, reliability folks to understand what's going on. And so, it's a fun mix of being out in this, loud, big plant and, then coming back and taking that information to your office and, doing some research, figuring out what's going on, right? Looking through our specifications and coming up with those solutions and fixes.
So Justin, you've been with this company since you said 2003 and even doing internships before then, right?
Mm.
How have you seen the entire energy industry evolve over time? And I mean, Chevron, big company, they have to make large capital investments and they have to be planning decades in advance. Where do you see this field evolving in the future? Do you see, for example, as renewables become cheaper, that Chevron gets even more into that area?
Our approach is pragmatic, we'll say, and it's a balance of business and political and regulation And so we have to set those business plans at a certain level. And so we tend to base our business plans off a dollar barrel of oil that we project. And those economic decisions about investing or going in a certain direction with the company, those don't happen at the refinery level, right? Those happen like at the strategic and corporate level. And so, we will certainly see and get to be part of, those decisions. But there's really, really, really smart business folks that are working on those kind of decisions for us, and they've done a great job. Right, we've been able to acquire companies. We just closed the acquisition of the Hess Corporation, and so that was provides us with a large portfolio and across the South Central America. Prior to that, we acquired some acreage in Colorado and New Mexico with Era Energy. We'd acquired the Renewables Energy Group. And so anyway, the business is constantly, just like any, right, in this flux of meeting consumer demand, meeting, regulatory demand, and trying to make those decisions. And so being here for 20 years, we see those cycles. Sometimes there's large investment, sometimes there's less investment. Refining, if you look at refining itself, is a very margin-based business, right? So supply and demand. We want to supply as much product as we can, right? We provide the consumer with fuels and all of our products, but sometimes there's hiccups that we have, and depending on who else is able to supply that. So we go through these investment decisions, and how many tanks do we put in? Do we need new tanks and all that fun stuff? But anyway, getting back to your question, for sure in the renewables space, here in El Segundo, we had a great opportunity to actually convert one of our hydro treaters into a 100% renewable diesel production from fossil. And so we actually put in new tanks, new pipelines, new train tracks to bring soybean oil into the refinery and turn it into renewable diesel. And so, talk about that economic and business assessment that happened, 3-5 years ago, came to fruition last year. And so that play between, like I said, regulatory and economic and business, ideas, you see that all over our company. We're good at hydrogen. And so, we started a partnership with Delta Energy up in Utah to actually provide hydrogen in partnership with, I think it's Solar Turbines, to power a power plant in Utah and then store hydrogen in the salt caves. We also are putting our expertise in natural gas to use just lately, partnering with to provide power to an AI station in Texas. And so we look to apply kind of where we're good at doing business with wherever we're going, kind of in a regulatory and political, I think, environment.
So there are many industries out there that have a lot of engineers. They produce products that are highly valued by our society. I was able to drive here today. Took a while on the 405 freeway, but I was able to drive here today very easily because of gasoline. I'm able to fly anywhere in the world because of jet fuel. We have trucks that transport goods all across the country. We have ships that transport goods across continents. People are listening to this podcast perhaps because they're getting energy from a natural gas power plant, right? But the combustion process does have some negative consequences. There's pollution, there's greenhouse gas emissions. We've done an amazing job of reducing pollution over the last couple generations. Maybe we need to do a little more with greenhouse gas emissions. But the reason I mention this is because there may be some engineering students right now who may want to work at a company like Chevron, but the negative consequences of, say, combustion are very visible or very talked about, let's say. But I look at life as all about trade-offs. There's no industry out there that is perfect. How do you view the trade-offs in your line of work?
So I think as a company as a whole, we're leveraging our strengths to safely deliver lower carbon energy to the world. But as Justin has kind of alluded to, we have look into the future in terms of greenhouse gas emissions, and we are taking proactive measures to to reduce our carbon intensity and carbon footprint in the future. And the way that we've been doing that is investing in carbon capture and storage opportunities, and also investing in renewable sources, and also looking for alternative sources of energy like hydrogen. I think we actually just installed one of our first hydrogen stations up in the Bay Area recently, but we've been looking at renewable alternatives here. We just did that with our diesel hydrotreater unit, being able to convert modes of operation between renewable and fossil mode. And then also looking at opportunities at our fluid catalytic cracker units, our FCC units, between co-processing. So we're taking active measures to manage our methane and greenhouse gas emissions, so that we can lower our carbon footprint in the future.
Yeah, and I think probably most people don't realize the amount of emissions control equipment that exists in this facility, and most of the pollution doesn't get out into the environment. You have like lots of monitors all around. If there's rain, as we were talking about earlier before this interview, you guys treat the runoff water. So
Yeah, a whole lot of what we do is safety, and that goes for safety of people and safety of the environment. Our roles in terms of keeping products on spec, to make sure you're not flying in your airplane and and the fuel you have is the quality you need. We do a lot to make sure the emissions that we can control, anything from call it like a catalytic converter like on your car. We have giant versions of that on our furnaces. We have teams of folks that go around looking with instruments for leaks, and they're sensitive enough that they can detect VOCs coming out of places they shouldn't be. We've got a fence line monitoring system that can detect constituents, and the public can come see this data of what's getting outside of the fence line. Like you said, the water treatment. There's tons of stuff we do to keep ourselves and the community and the environment safe. Another neat example of work we're doing here in El Segundo to capture emissions and operate in an environmentally friendly manner is actually quite interesting, because one of the byproducts of the hydrogen production unit is carbon dioxide. And normally carbon dioxide, it would just be vented into the atmosphere. And in this particular case, what we're doing is we're extracting that carbon dioxide flow and actually liquefying it and turning it into CO2 that you consume quite possibly in any of your beverage products. So it's kind of a neat use of technology and business, and all kind of in the name of environmental stewardship.
So you both joined Chevron with bachelor's degrees. So how important is getting advanced degrees in a company like Chevron, getting a master's degree, a PhD, an MBA? What kind of doors might that open?
Folks don't tend to come in with an MBA directly. Once individuals get in and maybe have more of a management track in mind, they'll go back and get MBAs. And so that management world, if that is something that you're interested in, and it's not a requirement even for that world, I'll say, but that tends to drive folks more to that business and strategic planning world. The advanced degrees and really like PhD level stuff, that's where we're looking for folks in our research type central organizations, not so much in the entry level. And then we will look at, of course, folks with masters and or bachelors. Quite honestly, you start in the same role, whether you have your master's or bachelor's as an incoming engineer. So the other cool thing that I will say about us is we have folks that we call Mustangs that are not degreed, that come up through the operations and maintenance ranks. We have management folks, right? We have leaders, supervisors, individuals that have come up the ranks. So regardless of degree or educational background, we've got great opportunities for folks.
How important is it to be professionally licensed in this field? So, passing your FE exam and then PE exam, You mentioned civil engineering earlier, Brittany, about how they all have their PE license. Is getting certifications important for some people in this company?
Yeah, I think for certain disciplines, it is definitely more proactive in order to have it. So as I mentioned earlier, civil engineering will be signing off on new drawings that come in regards to signing off on the systemic wind and structural loading calculations for new platforms, new structures, new foundations. And so typically, our civil engineers will be PE certified and have their license. As far as on the chemical engineering side, it is not a requirement, but I think if you definitely have the interest in pursuing and getting the FE and the PE certifications, it is not looked down upon. So I think it's going to be at the interest of each individual.
I'd suggest do it early. Do it soon out of school. The other place I'll add, I think, where we have like licensed professional engineers are in some of our subject matter expertise groups. So there's those central organizations that support, the entire company, very specialized materials folks, very specialized mechanical engineers. That's where we'll have other licensed engineers.
Are there other certifications besides FE, PE that are important for any engineers here? None off the top of your head?
Yeah, none off the top of my head. I mean, there are a ton of API, American Petroleum Institute certifications around inspections and those kind of things that you could get into, but that's a different career path than for engineers.
So if there's a current engineering student right now who's interested in becoming an engineer at a company like Chevron, what is Chevron typically looking for in prospective new engineering employees? How can they better prepare themselves for a career in an energy company like Chevron?
We look for, and these are kind of the generic things, technical ability, so GPA. We look for teamwork skills, communication, and extracurricular activities. And really what's going to get you in and it's the initiative and the passion you show for your discipline. If you come up to recruiters, and this goes for everyone, not just for Chevron, not just mechanical or chemicals, but you really need to demonstrate your passion for that field of study. And whatever you do to do that, and it's usually those extracurriculars. Are you a chemical engineer and you're part of the AICE leadership team? Are you an electrical engineer and you're part of the Power Engineering Society? The activities that you do will demonstrate that interest. And so being able to show that and have passion for that and good grades and have communication skills, that's all those kind of things that Chevron looks for. And I'd almost say, any company is going to want to see that kind of passion. Of course, folks that have prior experience or prior field of study, again, if you're passionate about chemical engineering, are you doing projects in chemical engineering? Are you part of, whatever AICE competitions or panels or whatnot? Show that interest through the things that you do. And that's what will get you noticed.
And you both did internships, correct? So that must have helped as well.
Oh, yeah, I think so.
Yeah, so I think as Justin had alluded to, we're just looking for well-rounded candidates, someone who's both passionate in their field of study, but also passionate in helping with community engagements, their extracurricular activities, but also looking for good soft skills. So the advice I can say, because Justin and I were both in your shoes at one point, is when you do come to us up to a recruiter, whether it's a Chevron or just be passionate, be confident within yourself, Practice your elevator pitch beforehand. Make sure you're not fumbling and whatnot. So I think the first impression definitely will set you apart from potentially other candidates, but then your resume does also play a factor. And I think Justin kind of outlined the criteria we are looking at. Between high school and college, make sure you're getting involved. Don't be a commuter. Don't just go to school, then go home, and kind of disconnect from campus life. I encourage you to get involved in clubs, whether that's related to your discipline, but also if there's other things like sororities, fraternities, or even chess club.
Were you in chess club?
I was not,
okay.
But it just came to the top of my head. But if there's other passions, right? Community outreach programs too, right? Helping out at soup kitchens, being a youth leader at your local church. Those are things that we want in a candidate to make sure that you're going to be someone that can blend into Chevron's culture, because that's something that we definitely take pride in here at Chevron, is making sure that you're both technically sound, but also someone that can mesh in with the Chevron way and Chevron culture.
Well, Justin and Brittany, thank you for taking time out of your busy day to have this conversation. I really appreciate it.
Appreciate it, Paul. Thank you.
Thanks so much.
Thanks again to Justin and Brittany for sharing what it's like to be an engineer at a large energy company. In case you're interested in learning more about Chevron, I've placed a couple links in the show notes. Before I go, I'd like to mention that if you're enjoying this podcast, there are a few ways to support it. You can subscribe to the podcast using your favorite podcast apps such as Apple Podcasts, Stitcher, Google Play Music, Spotify, and many others. You can rate the podcast and leave comments on whatever app you use to listen to the podcast. And finally, you can help spread the word about the podcast by telling your friends and family or anyone else that you think might be interested in this podcast. So take care, everyone, and goodbye for now.